Good day, everyone. Today I am going to discuss some of the concepts of mathematical logic, and these are the logical connectives and symbols and its truth values and truth tables. Let me discuss first the logical connectives and symbols. Letters P, Q, R, and S are symbols used to represent simple statements, while these symbols are used to represent connectives. These connectives are used in a compound statement. There are 5 types of statement. The first one is the negation. It is the opposite of a positive statement or affirmation, and the symbol used is this one. The second is the conjunction. It consists of 2 or more simple statements joined by the word "are" or by this symbol. The third one is the disjunction. It also consists of 2 or more simple statements and also joined by the word or the symbol, and it suggests that one of the statements is true or both is true. The fourth one is the conditional. These are the statements that require conditions to be true. They take the form of an if or then statement. They posit that if one thing is true, then another thing must follow. The symbol used is this one. And lastly, we have the biconditional. It is a statement that contains 2 conditionals, but each of the conditional implies and suggests the other. It usually takes the form of if and only if statements, and the symbol used is this one. And now, let us learn how to recognize a statement, their connectives, their symbolic form, and types of statements. We have the not P statement, and it has a connective not, and this is the symbolic form, and also this is read as negation P. This is the negation statement. Next, we have the P and Q statement. The connective use is and this is the symbolic form. This is now the conjunction statement. Then, we also have the P or Q. The connective use is or, and this is its symbolic form, and this is the disjunction. Then, we have the if P then Q statement. The connective use is if then, and this is the symbolic form, and this is a conditional statement. Lastly, we have the P if and only if Q statement. The connective use is if and only if, and this is the symbolic form. And this is now the biconditional statement. Now, I have here examples of simple statements which are represented by the letters P, Q, R, and S. Today is Monday is represented by letter P. It is a sunny day is represented by letter Q. I am not going to lay down on my bed is represented by letter R, and I am going to play badminton is represented by letter S. These simple sentences or statements that you see will be used to generate new compound statements using the logical connectives. First, we will have an example for negation. The letter we use is letter P. Today is Monday. So our not P is simply the opposite of the statement, which is today is not Monday. Next, we have the conjunction. The letters we use are P and Q. Our P is today is Monday and our Q is it is a sunny day. So our P and Q is simply today is Monday and it is a sunny day. Next is the disjunction. The not R or S. The letters R is I am not going to lay down on my bed. The not R is simply the opposite. So it is I am going to lay down on my bed. And S is I am going to play badminton. So now our not R or S is I am going to lay down on my bed or I am going to play badminton. Next is the conditional. Q implies R. Our Q is it is a sunny day and our R is I am not going to lay down on my bed. So now our Q implies R will be if it is a sunny day, then I am not going to lay down on my bed. And lastly, we have the biconditional. S, if and only if Q. Q represents it is a sunny day and S is I am going to play badminton. So our statement S, if and only if Q will be I am going to play badminton if and only if it is a sunny day. Let us now move to our next topic, which is the truth values and the truth tables. The truth value of a simple statement is either true or false, while the truth value of a compound statement depends on the truth values of its simple statements and its connectives. The truth table is a table that shows the truth value of a compound statement for all possible truth values of its simple statements. So, we'll look first the tables or the truth tables for the 5 logical connectives. Let's see the table for negation. If P is true, then not P is false. If P is false, then not P is true. This table is easy to understand. Remember that if P is true, its negation is false. And if P is false, its negation is true. Next, we have the truth table for conjunction. If P is true and Q is true, then P and Q is true. If P is true and Q is false, then P and Q is false. If P is false and Q is true, then P and Q is false. But if P and Q are both false, then P and Q is also false. As we observe on the table, P and Q should be true when both P and Q are true. Otherwise, it is false. Next, we have the table for disjunction. If P is true and Q is true, then our P or Q is true. If P is true and Q is false, then our P or Q is true. If P is false and Q is true, then our P or Q is true. But if P is false and Q is false, then our P or Q is false. Also, we can observe in the table that P or Q is true if P is true or Q is true, or both are true. It is only false if both P and Q are false. Next, we have the table for conditional. Our P here is the hypothesis and our Q is the conclusion. Our P implies Q. So if P is true and Q is true, P implies Q is true. If P is true and Q is false, P implies Q is false. If P is false and Q is true, P implies Q is true. If P is false and Q is false, P implies Q is true. Now, we see in the table that P implies Q is only false if the hypothesis is true and the conclusion is false. Otherwise, it is true. Lastly, we have the table for biconditional. If P is true and Q is true, then P if and only if Q is true. If P is true and Q is false, then P if and only if Q is false. If our P is false and our Q is true, then our P if and only if Q is false. If our P and Q are both false, our P implies Q is true. Remember that P if and only if Q means that P and Q are equivalent. If P and Q are both true, or if P and Q are both false, then it is true. Otherwise, it is false. We have to understand or even memorize the truth tables for logical connectives because this will be used in more compound statements. This ends my discussion. Thank you for listening. I have here some assessment. I hope you will try to answer them. Again, thank you for listening. God bless all.